In this lecture, you will learn about the file system used in OpenVMS, the file specifications, and how files are organized in directories. You will learn to navigate the directory tree and search for files and directories using different filters. Files are units that OpenVMS uses to store data. They are organized into directories. Normally, each user is assigned a directory and has privileged access to it. This is the user's default login directory. Complete file specification describes the access path that the system uses to locate and identify a file. It consists of the following elements: node, device, directory, file name, extension or type, and version. Node is a network node or host name. Note that it's followed by a double colon in the file specification. Device is the disk or another peripheral device on which the file is stored. Each device has a unique name that indicates its type and location. The device name is followed by a single colon. The directory name should be enclosed in square brackets or angle brackets. If you need to specify nested directories, use a dot as delimiter. The file name is separated from the file extension or type by a dot. The file version is specified last and is separated by the semicolon. OpenVMS allows many versions of a file in the same directory. Versions are identified by a decimal number, which is incremented by 1 each time a new version of the file is created. The system automatically assigns a version number unless you specify one. Different versions of the same file are actually different files with different file IDs, but they have the same name and usually refer to different revisions of the same file. A complete file specification can get very long once you have a lot of files and directories. However, quite often you do not need the complete file specification when you enter a command. Also, do not specify the node if the file is located on the node that you are logged into. The same applies to specifying the device and the directory. The file name plus file type, or just the file name, are often sufficient as OpenVMS assumes default values for most of the file specification fields. Let's look at the file specifications on the system. The show system command will give you the information about the node you're on. If I specify /no process, it will only give us the header of the output with the node name. So this is the name of the node that we're currently on. If someone wants to put files into my directory from a remote node, they will need to specify this name as the node name. Let's see what disk devices there are. Look at the device name column. Let me explain how to decipher these letters and numbers. OpenVMS uses one of the 3 standard formats for device names. The double D stands for the device code. C is the controller designator that identifies the hardware controller to which the device is attached. It is usually one letter from A to Z, where A stands for the first controller, B for the second one, and so on. U is the unit number that identifies a device on a particular controller. It's an integer that runs from 0 to 65,535. Node names or allocation classes can also be a part of the device name. You already know what a node name is. An allocation class is a number identifying the preferred path to a device that has multiple possible paths. It is included in the beginning of the device specification in between $signs. Notice that each of the valid formats always has a device code, a controller designator, and a unit number. The device code consists of 2 letters. The first one represents the device itself, and the second one represents its type. Look at the tables on the slide. The table on the left contains the common first letters, and the table on the right, common second letters. And below the table, there is an example of a device name. The one between 2 $signs is the allocation class. Then EK stands for SCSI disk. A means that the disk is connected to the first controller. 100 is the device's unit number on the first controller. The file you need may be stored in a directory that is located in another directory, and so on. To specify all those directories, enclose them all in square or angle brackets and separate them by dots. When you log into the system, you are located in your default login directory or home directory. It is important to distinguish between your default login directory, which is always the same, and just your current default directory, which can be whatever you set it to. Notice that changing your default directory will not change your home directory. If you need to access a file in your default directory, you do not need to supply any file specifications apart from the file name. To see what your current default directory is, enter Show Default. sysdevice actually stands for $1 It means that your default directory right now is called Fund560 and is located on this Fiber Channel disk. After the directory specification, we usually see a file name. File names have some restrictions about what characters you can use and how many characters there can be in a file name. It all depends on the file system structure used on your device. OpenVMS supports two types of file system structures, ODS2 and ODS5. To check which one is used on your device, issue Show Device and the name of your device /full. This table states what characters you can use if you have ODS2 or ODS5. File names in ODS2 can have up to 39 characters, including letters from A to Z, numbers from 0 to 9, underscores, hyphens, and $signs. In ODS2, file names are not case-sensitive. They are always stored in uppercase. In ODS5, the case is preserved. It also allows you to use more characters in your file names and file types. When interacting with other systems, such as Linux and Windows, it is useful to know how to deal with extended file specifications. To enable parsing of extended file names, you need to run a set process /parse_style = extended. After that, if you are on an ODS5 disk, you will be able to create files with ODS5 style names. If you are on an ODS2 disk, however, you will get an error. To disable parsing of extended file names, use set process /parse_style = traditional. The characters found in file specifications, wildcards, and parts of DCL, such as the period, comma, semicolon, square brackets, parentheses, braces, %, apostrophe, @, plus sign, equal sign, pound sign, and ampersand, as well as the circumflex, can be used in ODS5 file names. But in order to be interpreted as literal characters rather than special function characters, they need to be escaped with the circumflex. Let me show you how this works. First, I will check if my device supports ODS5. Then I will turn on parsing of extended file specifications. And now, as an example, I will create a file with a special character supported on ODS5. See, this is how the file name is displayed. After the file name usually comes the file extension, or the file type. The file type represents the type of information stored in the file, or its structure. It is separated from the file name with a dot. Many DCL commands work with the default file type. If the file type is omitted, the system looks for the file with the specified name and the default type. On the slide, you can see the default file extensions for frequently used commands. .lis is a text file extension similar to the .text extension. A file with a COM extension usually contains a command procedure or script. .exe means that it is an executable file. .pass, .c, .for, .cob files contain code written in the respective programming language. .obj files specify the object files, and .hlb, .olb, etc. are used for libraries. The last element of the file specification is the file version. It's a number from 1 to 32,767. If you do not remember the exact version of the file, it is possible to specify a relative version number. I'll show you what this means. I will create a text file named script.txt, and I will write "this is the first version" as the contents of the file. Now, when I look at the list of files in my directory, I see that there is only one file with this name, and its version number is 1. Next, I would like to create 2 more files with the same name, but different content. In the second file, I will write "this is the second version." And in the third file, I will write "this is the latest version." Now, when I look into my directory, I see that there are 3 files with the same name, but with different version numbers. So, how can we navigate them using relative version numbers? I will use 0 to refer to the highest version number. This way, if I want to see the content of the latest file named script, I will do type script.txt ;0, like this. Specifying just the semicolon also does the trick. Next, -1 after the semicolon refers to the second highest version number. If I enter type script.txt ;-1, we can see that this is the second highest version. That is the second version of the file. -2 will refer to the third highest, which in our case will be the first version. You can specify -3, -4, and so on, depending on how many versions of the same file you have. -0 refers to the earliest existing version. So if the file version is not specified at all, some commands will assume that you mean the highest existing version of the file in the specific directory. For example, the print command does that. However, you should remember that the directory command defaults to all version numbers. The purge command defaults to all but the highest version number, and delete has no default and requires a version number. We will come back to the purge and delete commands in a separate lecture.